Good day, guys. This is your tutor engineer. Today we'll be doing Newton's second law application. It's an exam question based on a grade 12 or also grade 11. So let's start with it. So question 4 says 4.1, state Newton's third law of motion in words. So I'm not going to write a lot of words, but if you were to state it in words, you would say when an object exerts a force on an object B, object B will simultaneously exert a force with in a direction which is equal in magnitude on the first object. So that's what Newton's third law says in words. So 4.2 says two blocks of mass 9 kg and 5 kg respectively are joined with an inelastic string of negligible mass. The strings run frictionless pulley. So okay, you've got two blocks. Let's just recap a bit. You've got two blocks, 5 kg, 9 kg. We have them here. So the string is frictionless pulley. It means it doesn't have any effects of friction. So we're not going to consider a friction due to a string. The 9 kg block is on a rough horizontal surface, while the 5 kg block is on an inclined surface at 25 degrees. So let's just look at the angle of incline. Here is the angle, 25 degrees to the horizontal. The force of magnitude 35 Newton is applied to the 9 kg block. Here is the force. And which is parallel to the horizontal surface, causing the block to accelerate at 0.24 meters per square second. Here is acceleration here indicated on the drawing. The 9 kg block experiences a 4 Newton frictional force which moves to the left. So since the motion is towards the left, the frictional force will move to the right, experienced by the 9 kg. So you're going to have a 4 Newton force in this direction here. Okay, now let's look at the first question. It says calculate the tension in the string that joins the two blocks. So the question is calculate the tension here on the string. Okay, it's easy to use the 9 kg block since you only have one unknown, which is T. Okay, so the way I would do it is to first draw a typical forces acting on object 9 kg. So the forces that are acting on it, firstly, it's the friction force, and then you've got this force here. Okay, let me just use a different color from here. So you've got this force here that you need to work out from the tension T, and then another force that's acting on this block is its own weight, which we can call it Fg. Then you have a normal force which is going to be acting upwards. As long as the block is resting on the surface, that normal force is in place. So obviously you've got the applied force of 35 Newton. So what I would say the sum of the forces, or I would say F net, which is the resultant force, is equal to mass times acceleration. So this is the F net in the x direction basically. So if you were to draw your axis, you've got your x direction on the horizontal, then you've got the y direction, which is vertical. So I'm considering the horizontal plane. So I would say and then the next thing would be I would choose this direction here towards the left as positive. So choosing that direction as positive, that means the direction to the right will be negative. So I would say 35 Newton, which is the applied force to the left, minus, since the frictional force is going to the right, so minus 4 Newton minus T. So that is minus T. The tension force in question is equal to mass times acceleration. The mass is 9 acceleration is 0.24. So this will become 35 minus 4 will give us minus 31 minus t is equal to 9 times 0.24. So 9 times 0.24 on the calculator will give us 2.16. Right, so from here on it's just going to be basic mathematics. I'll take 2 to the left hand side, it will change the sign, and t to the right hand side, it will become positive. So basically when you say 31 minus 2.16, it will give us 28.84 Newton. So basically what you have, if we were to summarize this is the 9 kg, we have T, which is 28.8 Newton, you have the small friction force 4 Newton, we have the applied force 35 Newton, and then you have the weight. The weight is Fg. If you like, you can say Fg times is equal to mass times gravity, then you've got the normal force. So that's it. Now let's go over to the next question. Draw the label free body diagram to show all forces acting on the 5 kg block. So now let's look at the 5 kg block. Here it is. So let me write here, that would be 4.2.2. The forces acting on the 5 kg block, firstly, it's on the incline like this. You've got the weight, which is Fg. Then, since there is a movement, it's going to experience a friction force, which you can call it Fk, kinetic friction force. Then the normal force is going to be perpendicular to the inclined surface. So you've got Fn, and then you've got tension. So how many forces have you got? You've got 1, 2, 3, 4. That should be corresponding with the number of marks for this question. So that is it. That's all for 4 marks. Then 4.2.3, calculate the magnitude of the net force acting on the 5 kg block. Okay, now let's have a look at that. The question is to work out the magnitude of the net force acting on the 5 kg block. So let me write here 4.2.3. I will say F net is equal to mass times acceleration. We already have the acceleration of the system, it's 0.24. Then we have the mass of the 5 kg block, so we'll say 5 times 0.24. That will be our F net. That means the F net will be, putting that on the calculator, you'll get 1.2 Newton. So that is going to be towards the left direction. So if you want to specify the direction, we'll say towards the left. Okay, so now let's look at the final question. Calculate the coefficient of kinetic friction between the 5 kg block and the surface. So we need to calculate the UK of the 5 kg block and the surface. Okay, in order to perform that calculation, we need to bear in mind the formula that we'll be using eventually. The formula is coefficient of kinetic friction times normal force is equal to Fk. If you can get the Fk for the 5 kg block and then the Fnet, sorry, the normal force of the 5 kg block, then we'll be able to determine the what you call the coefficient of friction. So now let's start with the Fn. Let's work out first the Fn. So when it comes to the Fn, we'll say here, okay, I'm in short of a space now. Let me just go further down. Okay, that is 4.2.4. I will say Fn. Now I'm looking at the axis like this. This is the x direction. which is in kind of tilted or inclined. This is now the y direction. So sum of the forces, first of all, I will say F net or sum of the forces. It doesn't matter whether you say sum of the forces or F net, it's the same thing. So I'll say sum of the forces in this direction, there's no movement, so it's equal to 0. So be careful of writing mass times acceleration. Even if you write mass is equal to mass times acceleration, which is the original formula, the acceleration in the y direction is 0 since there's no movement. So that's where the 0 is coming from. So I'll say Fn going up. If I choose up as positive, and then Fn going up as positive, and then looking at this, let me just show you. The Fg has got the perpendicular component to the surface. So remember, since the angle is 25, this will also be 25 there. Between the Fg perpendicular and Fg, that's a 25-degree angle. So I will say here Fn minus Fg perpendicular should give me 0. So that means Fn is equal to Fg perpendicular, which is equal to mass times gravity, right, times cos. Since the angle is, the side is adjacent to the angle of 25 degrees, so I'll say times cos 25 degrees. And then that means Fn is equal to mass, which is 5 times gravity, 9,8 times cos of 25 degrees. So putting that in the calculator will give us 44,4 Newton. Okay, now we've got Fn. Now let's work out the Fk and then we'll get the coefficient of friction. So, okay, just looking at this diagram once more, we'll consider the forces in the x direction. So we'll say sum of the forces in the x direction should give us, now in this case it's not going to be 0, so be careful, mass times acceleration. So since there's movement in the x direction, the acceleration is not going to be 0 since there is a movement taking place. So that will be equal to minus t, in fact we chose the left hand direction as positive, so the t is supposed to be positive. Since it's moving towards the left, that's going to be positive t. And then you've got the Fg perpendicular, which is acting on the horizontal direction in the negative direction since it's moving towards the right, so we'll say minus Fg parallel. And then you've got Fk going towards the left. That will give us mass times acceleration, which is the mass is 5, the acceleration is 0,24. Okay, now let's go right on. The t, we've just worked it out from the very first question. We calculated 28,8, so that is 28,8. In fact, it was 28,84 minus Fg parallel. Fg parallel is actually opposite to the angle of 25 degrees. So we'll use sin. So we'll say the mass times gravity times sin of an angle, sine of 25, then minus Fk, since we don't know what is Fk, is equal to mass times acceleration. Okay, then from here on it should be much more simpler. So putting all of that in the calculator, in fact let me just do it like this, 28,84 minus 5 times 9,8 times sine of 25 degrees. Then I'll take this to the left hand side, 5 times 0,24 to be positive, is equal to Fk. So putting all of the left hand side on the calculator, you'll find that Fk is equal to 6,892 Newton. Okay, since it's positive, it's going to be moving towards it's always opposing the motion. Basically, it's moving towards the right hand side. So now, since I know what is Fk and Fn, I'll come back to this formula to calculate the coefficient of friction. So that's going to be Fk divided by Fn. Fk is 6,892. Fn, remember with Fn we calculated 44. Let's just go right on top. We have 44,4 Newton. So let's divide by 8. 44,4. So that will give us 0,155. So that's it. If you like the lesson, please hit the like button and consider subscribing.